So many people doing chemistry cannot actually draw this diagram, right? This is like, okay, let's start from here. We are taking this property. Let's say CH3. We'll start from here to read it. Let's teach you how to read it. C, this is carbon, HH, that is one single bond, CH2. You can see we are reading it from the back. We're going here to CH2. You can see we are reading it. We are still reading it. This is also CH2. This is the tree diagram of it. Then the last combination is CH3. This is what they call the pentane. The pentane. Other day, everyone. This is Chioma Oji. I decided to delve into the chemistry field today. I hope I'm welcome, chemistry people. And now you rate me, chemistry people. It's Chioma Oji, the boss. So today I'm going to be talking about organic chemistry. I want to expose some things about organic chemistry. You know, the word organic, we simply think that, sometimes we think that, okay, it's living organisms that exist naturally and all that. So many people think like that, you know, when they say, oh, I want to use organic cream, you know, but something is very obvious in organic chemistry, and this is some materials or compounds are being synthesized in the laboratory. And then when they are synthesized, because of their economic, their availability and their biological use, they are now seen as inorganic properties. Example of that is carbon. Carbon is widely donated in the earth, and it has a lot of uses and combinations to chemistry. Now, what is organic chemistry? Organic chemistry is simply the study of carbon compounds. Okay, so like I said before, some compounds are taken to the laboratory, and when they get to the laboratory, they are synthesized. And when they get synthesized, they turn into organic compounds that can help us in organic chemistry, e.g. carbon. Some other carbons that are seen as inorganic are the oxides, are the metallic carbides, are the trioxocarbonate 4. These ones are seen under the properties of what? Inorganic. But the rest of the carbons, they are not inorganic, they are purely organic. Carbon is seen in large number, and it has a lot of biological, chemical, economic use, and that's why, because of the after synthesization, and that's why it's seen as what? An organic compound. Hence, organic chemistry is the study of carbon compounds. So let's write. Mainly, organic chemistry is made up of what? First of all, main element is carbon. Main element is carbon for one. Then two, there are other elements. You have like the oxygen. You have the halogens. You have the hydrogens. Then you have the sulfur or phosphorus, sulfur, etc. And now you should know that carbon compounds are a lot. Why are they a lot? Because of the ability of carbon compounds to catenate. There's something they call catenation. You know, catenate. So you can say catenate. You know, combination with other like nitrogen, oxygen, phosphorus, halogens to form long chains, branch chains, you know, ring chains, etc. Long chains, branch chains, ring chains, etc. Carbon compound is a lot in the world. We have it so much in the world. That's why it's taken as one of the major study of organic chemistry. See, the bonding property and energy of carbon is very strong. We have the single bond, the double bond, and the triple bond. Difference between the single bond and the double bond is the triple bond has a higher energy bonding than the double bond, because the double bond is just appearing to have something like the sigma bond in the sp shell orbital, right? But in the triple bond, you have the sigma plus the pi. The sigma plus the pi. So sigma plus the pi will give you equal to triple bond. Okay, when we start doing the sp shells, I'm going to show you this. We will get to that. Okay, so chemistry people, you can take notes and continue from where I stopped. So I'm going to teach you about the single bond. The single bond, the energy there very high. Like let's say the carbon to carbon bond, you have the 846 kilojoules. You can say that. Okay, let's say the nitrogen to nitrogen, 163. Am I correct? 163. Then oxygen to oxygen, we have 146. Then you have silicon to silicon, we have about 173. These are in kilojoules. These are the kind of energy for single bond. Then triple bond, you have a sign like this. S is S, but all connected to carbon. So lastly, because carbon is highly available on Earth, let's talk about how we can use just 5 carbon to form 3 or 4 different carbon compounds. It's funny. That's why they said organic chemistry is really the study of carbon compounds. Let's go. So let's form a pentane. A pentane is C. Oh, this marker is not working. Let me get it. So let's form a pentane. A pentane is C to C to C to C. 1, 2, 3, 4, and another C. That is 5. So now let's form a pentane. This. These are the bonding, these are the bonding. So you have 1 hydrogen here, 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 1 hydrogen. So many people doing chemistry cannot actually draw this diagram, right? This is like okay, let's start from here. We are taking this property. Let's say CH3. We'll start from here to read it. Let's teach you how to read it. C, this is carbon. HH, that is 1 single bond. CH2, you can see we are reading it from the back. We're going here to CH2. You can see we are reading it. We are still reading it. This is also CH2. This is the tree diagram of it. Then the last combination is CH3. This is what they call the pentane. The pentane. This is under the alkane family. The pentane. So this is one. We have so this is one. The first one, 1, 2, 3, 4, 5. You can see we've used 5 carbon with 12 hydrogen. 5 carbon with 12 hydrogens. Using this kind of tree diagram, or look at
this. Not to all the students where they hustle, to the queens and kings where they burn night candle. This not your magic scholar with fire. Founder of CHI-BBT Online Academy. Let's go. Scholar never give up. Now small we they gather sense. Just stay on track. Scholar never give up. One day you go get the crown if you no give up.